So multiple slits, we also sometimes call these gratings. So a grating, like if you think of a cheese grater or a sewer grating, basically it's lots of openings, right? Many, many openings. And if we were to send light through this, okay, we were to send light through this, what you're going to get is a interference pattern. Remember, on each little opening, there's going to be, the light's going to bend, and what do we call this? Diffraction. This is a principle of waves again, property of waves, that they diffract. And then on the back wall, we're going to get this nice interference pattern, just like before. Now it is important to understand that these openings do not correspond to the openings in the grating. In fact, the closer these are together, the closer the spacing, the wider the spacing of these points back here. Okay, the fringes spread out. So this would be our pattern that we get over here. Kind of the key thing with the gratings is all the things we did with the double slits, these apply with the multiple slits. These apply with the gratings and the multiple slits. And in other words, this is the 0th order. If this is the first bright, and again, you may want to use colors again today. This was the second bright. This is the third bright. In all three cases, the concepts are the same. In other words, the first bright occurs with a path difference of, anyone remember? What's the path difference for the first bright? 1 wavelength. What's the path difference for the second bright? 2 wavelengths, and so forth. So these are all whole numbers. What's the path difference for the first dark? This would be the first dark. PD equals 1/2. And so forth and so on. So this would be 3/2, this would be 5/2. So far nothing's changed, and you're going to do the math is going to be the same. In other words, we're still going to use sine theta equals m lambda over d, tan theta equals x over L, and for small angles, m lambda over d approximately equal to x over L. So nothing has changed here. These are all going to be the same. Okay, so the next question is, well, what's the difference? What are the differences? So with the gratings, so differences between, and mathematically speaking, how you're going to calculate things, it's identical. What the m's are, it's identical. The equations are identical. The difference is really a visual, okay, what happens visually. So difference between double and multiple. The key conceptual difference is there's going to be more destructive interference. Interference. More destructive interference, which means there's going to be a lot more cancellation that happens. So if we look at this picture here, so you have all these, in the double slit you basically have those 2 beams that you would look at. In the multiple slit, like this 1, 2, 3, 4, 5, you have 5 beams that you have to look at. And when they all come together at one point, you get that full interference pattern, the full constructive. However, all along the way, you're going to get lots and lots of destructive interference, which means you're going to have a larger region of dark space. In fact, the more slits you have, okay, the more, like if you went from 3, 4, 5, 1,000, the more dark space you end up with, the more destructive interference. And what this ends up doing is it produces more clearly defined bright spots. Your bright spots are going to be more clearly defined. Now when we do the lab tomorrow, you're going to kind of see this visually, okay, firsthand. I'll try to kind of draw some of this for you so you can visualize it as well. So we have D here. And remember, D means what? Distance between the slits. Okay, now they will often tell you that, but more often what they'll tell you is the slit density. And the slit density is the number of slits per meter. Number of slits per meter. So they oftentimes will tell you that. So for example, and actually they usually don't even say per meter, but they might say per like centimeter. So maybe let's do that, 1,000 slits per centimeter. Well, if they give you that, you will want to convert it first. So how many slits is that per meter? Is it going to be more slits per meter, or is it going to be less slits per meter? More, okay? So if you're not sure, I mean, just think about it. Here's a centimeter. If I have 1,000 slits in a centimeter, if all of a sudden I have a meter, there's going to be more of them, right? So we multiply it. So this can be 1, 1, 2, 3, 4, 5. So 100,000 slits per meter. Okay, now in your equation, we don't have slit density. We have D. Well, what's the relationship? Anyone derive the relationship between those two? So this is slits. Look at this. Look at the units. This is slits per meter. We want the number of meters between the slits. So what would we do? Take the reciprocal. So D is equal to the reciprocal of the slit density. Because look at it. When we reciprocate this, we get the meter per slit. So this would be the distance between each slit, the meter per slit. So in this problem, for example, you'd have 1 meter over, what's this, 1, 2, 3, 4, 5, 10 to the 5th. So that would equal 1 times 10 to the negative 5th meters. Alright, so that's often a calculation you do need to make. They'll give you, instead of D, they'll give you slit density.